Hello and welcome to the ultimate guide to the perfect RF signal generator. I'm Alan Gonzalez, and today we're going deep into everything you need to know about choosing the right RF signal generator for your needs. At Berkeley Nucleonics, we pride ourselves on offering high quality signal generators that cater to a wide range of applications. So, whether you're working in research, telecommunications, or defense, our tools are designed to meet your most demanding requirements. Today, I'm joined by our expert engineers, Edgar Guzman and Luis Cortez. They bring a wealth of knowledge and experience in the field. So, Edgar will be exploring the key features and specifications that set our generators apart, and Luis will showcase some of the cutting edge applications these devices are capable of. So, whether you're a seasoned expert or if you're new to the world of RS signal generators, this guide is tailored to help you understand the critical factors to consider and how Berkeley Nucleonics' technology can help you achieve unparalleled results in your projects. So let's dive right in. So before we begin the presentation, we'll have a poll question. Submit your answers. Have you used an RF microwave signal generator before? No harm to you if you haven't. No harm if you've only seen them in a textbook. But if you have used an RF signal generator, include that in the poll question. We always want to know what our customers are doing with this type of equipment. So feel free to submit your answers in the poll question below. Let's talk about RF signal generators, the unsung heroes behind the scenes in a variety of instruments. These tools are not just pieces of equipment, they're the backbone of testing and development for everything from smartphones to satellite communications. Whether you're tuning up telecommunications gear or ensuring that a defense system is up to spec, these generators play a critical role in your success. The beauty of RF signal generators lies in their versatility. They're used everywhere from the labs of aerospace to engineers testing avionics to automotive manufacturers calibrating equipment, radar systems for the next generation of smart cars, and even in consumer electronics to make sure your newest gadgets work smoothly right off the box. So now choosing the right RF signal generator isn't just about picking a product off the shelf. It's about asking the right questions tailored to your specific needs. So, what frequencies do your projects involve? Are we talking about something as low as the AM radio band or as high as gigahertz frequencies used in radar and satellite communications? The power output also matters. So, how much juice do you need to simulate real world conditions effectively? And let's not forget about phase noise, especially if your work involves sensitive communication systems where clarity and accuracy are paramount. Also, think about the types of modulation your applications will use. Are you dealing with straightforward AM or FM? Are you stepping up to more complex digital schemes like QAM? This will guide your choice in terms of the generator's capabilities. But then there's a practical side. How many channels do you need? Are you looking at generating multiple signals simultaneously? And what about the size and the type of chassis? It's not just technical specs, It's also about how the equipment fits into your workspace. So all of these factors boil down to one thing: finding an RF signal generator that fits like a glove for your projects. I know it's a lot to consider, which is why you'll want expert advice to steer you in the right direction. That's where Edgar and Luis will come in with their extensive experience. They're here to help you shift through these details and pick the perfect tool for your needs.
Hello, everyone. My name is Luis Cortez. I'm one of the engineers here for Berkeley Nucleonics. I have a background in electrical engineering, and prior to reaching Berkeley, I worked for the U.S. Army with a background of field artillery and conducting electronic warfare. Jumping into the importance of RF signal generation, an RF signal generator provides a stable signal source for testing and evaluating electronic circuits and devices. Because there are so many different applications for this type of equipment to include radar, electronic warfare, quantum computing, cellular communication, satellite communications, audio and video broadcasting, automotive technology, and much, much more, it is impossible to have an RF signal generator that is a one stop solution for everything. This limitation is why it is so critical to find a unit that can meet the requirements specific to your research demographic. A unit that is fit for purpose to your area of interest will ultimately generate more desirable, consistent, and timely results. Providing a unit that is both accurate to your technical requirements and user friendly is a desired end state for us here at Berkeley Nucleonics.
Hi, I'm Edgar Guzman, one of the application engineers here at Berkeley Nucleonics. And my job, along with Mr. Cortez here, is to kind of guide our customers towards products that fit their applications, mainly depending on certain specifications, which we will go over in this. So we're talking frequency range, power range of a signal generator, even the certain modulations and the different types, whether it be a digital modulation or an analog modulation. So those are some of the things that we will use to guide you towards our products that'll help you with your application. And I hope that you learn something from this webinars that you're able to, put into your work and just, allow us to assist you in making your application flow better in terms of how you design it from design to finished product.
Regarding RF modulation, there are two types of modulation categories that branch off into many different modulation techniques. The first type is analog modulation. Analog modulation includes amplitude modulation, frequency modulation, and phase modulation. The other category is digital modulation and includes modulation techniques such as amplitude shift keying, frequency shift keying, and binary phase shift keying, amongst others.
Here at Berkeley Nucleonics, we have a wider array of different types of signal generators that offer different types of modulations, from our standard modulations in the analog domain, such as amplitude modulation, frequency modulation, phase modulation, to our digital modulation with our VSG, our vector signal generator, where we have the different digital schemes that you would need for digital communications or even quantum computing, whether that be QAM or in any other digital modulation that you can think of.
Generally, when we examine digital signals, they happen to be more reliable because of interference or noise can be removed from the received signal. For those reasons, there's a lot of noise immunity. And because of that, you will also experience bandwidth efficiency. The digital modulation can accommodate larger amounts of data. And again, because of that physical limitation uh, in data transmission, digital modulation can transmit more data than analog. There's an abundance of modulation techniques, including quadrature modulation, which we will discuss in depth when we move on to the topic of vector signal generators, which Ed touched on. It goes without saying that the modulation type that a unit can perform is very important, emphasizing the crucial role of selecting a signal generator that can meet the modulation requirements for your project. One example for a potential application is radar. So if your team is working on X-band, you need to ensure that your unit can at least reach 13 gigahertz frequency and is capable of pulse modulation and meeting your pulse width and potentially switching speed requirements. For a signal generator, power is the amount of energy per unit of time that an RF signal delivers to a load. This measurement is specified in dBm or decibels relative to 1 milliwatt. In most commercial signal generators, you'll see a common power range of negative 120 dBm to plus 25 dBm. Some units have adjustable power, while cheaper RF sources may not, but you can always increase power with the aid of an amplifier or decrease it with the use of an attenuator. Recently, lower and lower power range floors have become increasingly popular for RF signal generators and lab use. This is due to the scale at which we are now fabricating chips. Nanofabrication, which requires significant attention to the power output, is why Berkeley has developed units specifically geared toward having a stable yet controllable power output and range.
So, kind of piggybacking on what my colleague said, the power range is very dependent on the application. Some customers need lower end levels, so we have the units that have the much lower noise floor in terms of how low they can go with their signal, and then we have other signal generators that have the HP option, which allow them to go up to 20, 25 dBm. But once you get to those noise levels and you start increasing frequency, it's very difficult to maintain your power level. So a lot of the times we end up recommending that people use external amplifiers, as Luis mentioned, when he spoke earlier. And then we have some customers that will get a synthesizer and they don't need the higher power output, so they'll use an attenuator to lower it down. So it just kind of really depends on the application and what specifications you're going for and how you choose your signal generator or synthesizer.
The workhorse of the BNC RF units, the Model 845, was designed to meet a variety of power range requirements. The standard unit operates at negative 20 dBm to plus 20 dBm, but with a combination of the PE2 and HP options, can be extended from negative 120 dBm to plus 25 dBm.
Okay, let's ask the audience our next poll question. Submit your answers. What frequency ranges are you working with? Is it AM? Are you doing 10 gigahertz, 20 gigahertz, 50 gigahertz, 100 gigahertz? What frequency ranges are you currently working with now? Or you can even include frequency ranges that you foresee yourself and your group needing in the upcoming months or a year.
Radio frequency is a measurement representing the oscillation of the electromagnetic radiation spectrum from frequencies ranging from 300 gigahertz to as low as 9 kilohertz. It is now commonplace in the RF industry to see teams working in a wide range of bands, stemming all the way from low frequency or LF band to the V band and working at around 75 gigahertz. With such a wide range of operation, it is important to pick an RF signal generator that is specifically designed for the frequency band under observation. For example, an RF signal generator that is able to output from 100 megahertz to 60 gigahertz might be an excellent choice for folks working in the Ka and lower V band, but it could also have subpar noise performance in the lower bands compared to what you might see on a signal generator specifically designed to work at a frequency ceiling of only 3 to 6 gigahertz. This is also important to keep in mind for certain types of research, such as EMC testing. Because of the nature of this operation, you will need 2 or 3 signal generators to fully and accurately provide data for the various frequencies that the device under testing will be observed.
So just kind of add a little bit more to that. While the frequency is extremely important, there's one thing to keep in mind. It is very application dependent. There are some applications, as Luis mentioned, where they are very strict in the frequencies they need to work under. And then there's applications, whether that be certain chip developments or digital communication development, that while the frequency is important, having a range of frequencies can also be important, as well as future proofing for future higher frequencies. So you if you're only working in, say, 20, 25 gigs, you don't necessarily need 40 gigahertz or higher, but it doesn't hurt to have them. if you think in the future you may use those higher frequencies in different development or just different projects in general. So that's something to keep in mind, depending on your budget and where you see your projects going in the future.
Keeping all of this in mind, Berkeley Nucleonics has designed the new Model 870A to have low noise and improve long-term frequency stability for testing. It also includes variable external reference inputs for testing that requires an even higher level of precision from an oscillator, such as satellite vehicles which use rubidium or hydrogen maser clocks. Single and multi-channel output generators are exactly as they sound. The difference is between a unit having a singular RF output as opposed to having more than one. You will usually see multiple channel systems in research and development applications for GPRS receivers. Researchers will replicate multiple frequencies simultaneously for a higher level of precision regarding position. Researchers will also use multiple channel signal generators for projects that include harmonics. Generally, you'll see a carrier wave for the primary channel and slew of RF waves at harmonic frequencies to channel 1. In quantum, you will see multiple RF sources function simultaneously when work is done on qubits in order to elicit entanglement. In communications, this is very common and amongst beamforming. Beamforming is a type of RF management technique when multiple antennas in close proximity of each other send out multiple frequencies directly to a device as opposed to an omnidirectional manner. Suddenly, those 2.4 gigahertz and 5 gigahertz settings on the common household router are making a little bit more sense to the non STEM folks on this webinar. Lastly, multi-channel units are used in cyber warfare to emit EMI or electromagnetic interference. By conducting multiple frequency sweeps simultaneously on different bands, you are essentially flooding the RF spectrum with noise that will enable coherent communication between a receiver and transceiver device. You're essentially jamming them and rendering them to a degraded status. A single channel output unit is the continuous wave source of choice for most testbed applications. Although multiple channels can be a requirement and are generally a budget friendlier option compared to buying multiple units, there are occasions where it is a requirement to stick to only one channel units. This is common in the aviation industry for many safety of life applications. Systems are specifically designed so that if one goes down, there is a backup as opposed to a singular multi channel unit that goes down, and now that requirement or feature is rendered completely inoperable or unresponsive across all channels.
In regards to phase coherence, and we'll talk a little bit about phase coherence switching later, I believe, but it's extremely important depending on your application, especially in quantum computing and digital communications. You need to know that the signals coming out of your unit are coherent in their phase. They do not drift around. So what you're sending out isn't shifting and giving you unnecessary phase data that may be completely useless in what you're doing and may actually turn the information you're trying to get into nonsense pretty much. So phase coherence is one of a very important aspect of certain multi-channel signal generators, and Luis will talk about one very specific example uh, that we are very proud of here at Berkeley Nucleonics, and that's the 855B.
As Ed just mentioned, Berkeley Nucleonics has fabricated multiple channel sources that are a common requirement for the automotive, defense, and space industry. The Model 855B multi channel signal generator was designed to meet current industry research requirements. One of the unit's biggest features is the ability to conduct phase coherent switching. This means that as a unit switches frequencies, the unit will always maintain the same phase regardless of the new frequency it begins to output. In industry, this has also been described as phase memory. As Ed touched on with data, this is of particular importance to the folks working in the quantum industry in order to ensure a high degree of communication between qubits when manipulating matter. Vector signal generators are a special breed because they can perform quadrature modulation. This type of modulation requires a Q and an I source, and what the generator does is manipulate the phase of the Q source so that it is in quadrature to the input I or reference carrier. Quadrature is in reference to a 90-degree phase shift, which is what makes the Q source orthogonal to the I source. In comparison to an RF signal generator, a VSG can perform all requirements that a standard RF unit would perform, but its ability to conduct quadrature modulation and a combination of both analog and digital simultaneously is what a standard RF signal generator, regardless of the brand, would not be able to perform. The requirements of a vector signal generator are becoming commonplace, especially in the defense industry for both radar and encrypted communication applications.
So a vector signal generator, as my colleague said, can do either analog or digital modulations, whether AM or any type, QAM, any type of modulation scheme you need, whether that be for quantum computing or digital signal processing, digital communication. If if you need the modulation, odds are a vector signal generator can do it. So it's becoming very commonplace in research environments and application environments where they're designing new systems for digital communication. Part of the reason why the vector signal generators are becoming so popular is the benefits and the advantages of IQ signal modulation, which is something my colleague Luis will talk about.
Thank you, Ed. As you mentioned, quadrature modulation is becoming more and more popular as the RF spectrum continues to evolve and become more and more congested. IQ modulation promotes spectral efficiency, while regular signals generally require upconversion through a carrier because they are naturally baseband. This process has a tax that includes using more bandwidth, generally double the original, with no additional data added. Anyone who has ever worked at OSM or the Office of Spectral Management will agree that this is too much bandwidth to waste with absolutely no benefit. Through IQ modulation, one can transmit two signals of the original bandwidth over a channel of double bandwidth in order to maintain the average spectral occupancy at the original bandwidth per signal. To meet the growing need of this industry, Berkeley Nucleonics has designed the Model 875 vector signal generator. This unit includes pulse descriptor word feature and an RF bandwidth of 400 megahertz for the internal IQ modulator. Phase noise is the electrical noise caused from the short-term fluctuations that occur in the signal. If we imagine an XY coordinate plane, and on the center of the plane we begin to plot a sinusoidal wave, in a perfect world, that sinusoidal wave is just there. It exists. It does not move and it does not change. The unfortunate reality is that this perfect sinusoidal wave does not exist amongst RF signal generators. And so a horizontal deviation from the ideal sine wave on the XY coordinate plane is what you would see and what is known as phase noise. Similarly, if we had a vertical movement on the y axis in the coordinate plane, this is known as amplitude noise. Generally, lower phase noise is considered an overall improvement to the system, but one should remain cognizant that lower phase noise also implies a slightly lower power output. We often see a lot of low phase noise applications come from the aerospace industry and more recently the quantum computing sector. We have also seen an uptick in low phase noise requirements as the 5G mobile device industry grows and a battle ensues to use the bandwidth in its entirety without impeding on other devices and equipment. For an RF signal generator, switching speed is the time it takes the generator to switch from one frequency to another. Switching speed is an important aspect for frequency and amplitude control in specific configurations. The current RF industry standard is for most signal generators to have a switching capability between nanoseconds to milliseconds, depending on the oscillator and the unit architecture. Highly precise switching speed is a requirement in applications such as encrypted communications. Frequency hopping is a common methodology for this application. As the name implies, you need a very agile and precise unit to meet this requirement.
So when we talk about switching speed, the question always comes up: is faster better? And that's all not necessarily true. It's very much dependent on the application. Sometimes you can get away with standard switching speeds in the microseconds, maybe even depending on your application, the milliseconds is something that's that you can work with, and it won't hamper any of your measurements or anything like that. So it very much depends on the application and how fast you can read the signals you're sending, regardless of if you're sending them quickly, can you actually do anything with the data at the speed you're switching it? So, generally, that's something I would say to our customers. Talk to us, talk to the engineers here at Berkeley Nucleonics, so we can kind of break it down to see if you know the faster switching speeds are something that you need. If we even have anything that will meet your switching speeds, but it all basically is dependent on the application. So a faster switching may not necessarily be better. It's just very much dependent. Having said that, switching speed is very important in a lot of applications in terms of whittling down the time it takes to actually do measurements or communications. So if you're sending or you're switching your frequency thousands of times and you need to do it as quickly as possible, that's where switching speed is actually something that's extremely important to you there. So it really does depend on the application, like I said earlier, but the faster switching speed can make your testing much more efficient and faster. It just really depends on what you want out of the data you're switching. Next, we're going to talk about the different dimensions of our signal generators. And if you ever browsed our catalog, you see that we have the large units that are rack mounted, whether that be a 1U up to 3U, the very large pieces of equipment that are usually the multi-channel, but that's not necessarily true. But it kind of depends on what you're going to be doing with the RF signal generator. So if you're using it in a research environment, generally a tabletop unit would be something that is beneficial to you. They generally have a touch screen, so you can use them without having to use a remote system, a computer to interface with it. A lot of labs, as most people know, have rack mounts in them, so it may be beneficial to have a unit that's capable of being rack mounted, regardless of the size. And then there's other things to take into account if we're using the signal generator in actually developing a product. So when we get to that, we have little OEM versions that are, this tiny to once again, the rack mounts that can go cleanly into a rack with all the other instrumentation, and that can be grouped in to the product that you're making. So the dimensions are significant, and but basically are reliant on what you're using the signal generator for. Now, keep in mind when you do have the smaller units and the rack mounted units, cooling is something that you need to be on top of. The smaller units, little OEMs, generally need a heatsink or some sort of, cooling, whether it be active cooling or the passive cooling with the larger heatsink. So basically, the dimensions are very dependent on how the instrument is going to be used and what environment they're being used in.
Outside of the lab environment, there are requirements for RF sources where a conventional benchtop model simply won't suffice. These non standard applications require a physical adaptation to the unit. Berkeley Nucleonics has addressed this by designing the Model 845 OEM and the Model 805, as well as plenty of rack mount variations to many of our standard units. These physical changes make our systems easily integrated into pre existing lab racks or easy to install components in larger systems. In some of our designs, these compact units only take about as much space as two iPhones. These units were designed to perform under austere conditions while simultaneously maintaining a low physical signature and remaining inconspicuous. Some of this also includes DoD or military application, such as integration into counter ID systems or man portable radar systems.
When it comes to our signal generators, a lot of the questions we get asked is how can we interface with it and use it remotely, whether it's going into a larger system being rack mounted, or it's just you wanted to integrate it into a script that uses other different systems in conjunction with that. So our signal generators have a plethora of different connectivity interfaces, including Ethernet, USB. GPIB is also an option, even though it's more of a an older standard. We still support that because I know a lot of the DoD labs and research labs you still use GPIB. We also have our FCP port, which is our fast communication port to interface directly, with the system. So you're getting quick communications when you're sending your data directly to the FPGA. So the different benefits of each system is something my colleague Luis is going to go into right now, actually.
Thank you, Ed. The benefits of each connectivity option are that there are multiple ways to interact and communicate with a particular unit, either in person or remotely, as he mentioned, via script. These options were created with the end user in mind so that a unit could be seamlessly integrated into an overall system and that the system could be operated and monitored remotely. The system could also just as easily be configured and adjusted manually. It is important to note that on OEM units, there are limitations for connectivity options because of the form factor. For that reason, these units will only have a singular or at most two connectivity options. They will not have the range that you see on the standard benchtop units.
And we have one last final poll question. This is this is going to be for the big bucks. Person that provides us with the most unique and best application will receive our BNC shirt. Everyone loves our BNC shirt. You probably have one already, so it's okay to have another one. So, poll question, submit your answers. What's your application? How do you use these RF signal generators? Quantum computing, radar, or are you just using it as for modulation? No modulation. What is your application? What industry? Most unique will get a BNC t shirt.
In terms of telecommunications, how you would pick the type of signal generator that works for you is very much dependent on which aspect of telecommunications that you're trying to either emulate or test, whether that be the LO signal going into your amplifier up, or mixer, or the carrier wave that you're using to send uh, your modulated data. We can even, go into the VSGs where VSG is very useful for digital communication using quadrature modulation to mimic a 5G signal or a Wi-Fi signal or a Bluetooth signal. So pretty much any digital signal that's capable of transmitting data. And then we have it in the terms of reading data that we've sent out over the air. So we have it come back. We also need signal generators that are clean, low phase noise to be able to interpret the data, filter out the parts we don't need to get the actual information that we're trying to send. So it very much depends on what part of telecommunications your research is focusing on, um, because you may even find a need for phase coherent switching if you're doing beam forming, and anything that requires coherence between your sources as they switch through frequencies. So it's just very much to that's where we come in. You have you come and talk to us, and we're able to help you decide on which signal generator would best fit your telecommunications application.
Both defense and research applications use multiple channel units with phase coherence. Despite having substantially different applications, the phase locking between channels ensures excellent clock synchronization. In the world of quantum research, this ensures accurate state prediction for qubits while they're being manipulated via RF input. In the defense side of the house, excellence in communication to modulation is one of the best ways in which we acquire electronic intelligence or ELINT. So today we have discussed the following aspects of an RF signal generator: modulation capabilities, power control and range, frequency range, number of channels in a unit, switching speed, phase noise, unit dimensions, and lastly, the various connectivity options for a unit. All of these are important to consider when selecting an RF unit for your configuration. We hope that the webinar can help engineers and non technical experts alike to understand the various facets that should be considered when selecting an RF signal generator for a particular project. Alan, what do you have to add?
I'm going to share my screen and kind of give everyone a good point or a good product page to find our signal generators. We've been doing this for over a decade. So let me share my screen. Here's my screen. I'm going to share. So if you go to products, the drop down menu, you'll see customize your RF signal source. Click on that. It's going to take you to this page where you'll be able to include your specific information. We've been, like I said, we've been doing this for a lot of years. We have various products ranging from low frequency to 10, 20, 30, 50 gigahertz. So we do have a wide range of instruments that we've introduced throughout the years. If you're unsure, you're looking at some of these products, you're looking at some of these models, I would recommend you start here. You go in there, you talk about what your application is. If you're dealing with quantum computing, if you're doing R&D, include that in there. What frequencies you'll be working with, what kind of power you need. If you don't have this information, you could just include unknown. But the more information we get from you, the easier it'll be for Edgar, Luis, our sales engineers to provide you with that perfect instrument. And full transparency, we're coming out with newer instruments, high density, better phase noise, different packages that even though it's not necessarily on the website, we will be introducing it in the upcoming months. So go in there, include your requirements, how many channels, how many units you need, right? We talked about the specs, we talked about the capabilities, we talked about all this fantastic technical, but we have to be realistic. Budgets, funding, right? We want to work within your specific needs. So having that information there will also allow our engineers to guide you in the right direction. Comments, anything else that we might need. A lot of the products that we have now are because of you, because of your work, because of your requirements, because of a lot of these new unique applications. So go in there, fill out the information. If you already know the product that you want, you would simply click on the learn more. And this is our complete index of, to some degree, off the shelf instruments that we have that we've been selling for, like I said, over a decade. And some of the biggest customers in defense, in quantum, radar, antenna. We work with some of the best companies here in the US, in Mexico, in Europe that help us with the development of this equipment. So if you already to some degree know what instrument you want, go to the complete index. Our A45 is there, OEM instruments, multi-channel, vector signal generators that we discussed. If you already kind of have a good understanding of where you're going, go in there. But if not, and if you're new to BNC, check out this page. And like I said, Edgar and Luis, they'll help you find that perfect signal generator. Okay, we're gonna open up to some Q&A. I'll stop sharing here. Any questions? Anything else that we can support you with? Do we have some questions on there? Looks like app notes. No real questions. After this call, we're going to be sending everyone links to some of these pages. Like I said, we're going to be sending links to the recording. So if your colleague wasn't able to attend, by all means, send them the link. If, again, you're a bit unsure about what your requirements are, if you simply go to this page, you include as much information, our specialists here at HQ will be able to support you. If not, our representatives throughout the country here in the US and North America, Mexico will also be able to provide you with technical guidance. Any questions? Edgar, any final talking points before we sign off?
I mean, I think we covered it generally, everything in the on all the slides we covered. I do see there are a few questions coming through. Um, we don't really offer cooling devices. Normally, they're either built into a unit or you would have to like actively cool something, whether that be water cooling, air cooling, in like a rack mount. So, and, anything jumping out of you here, Luis?
I'm not seeing anything on my end, Ed.
Oh, I guess I'm the only one seeing them.
And the right, I think we got one that says, is it possible to use in WISP applications? And that's and WISP is wireless internet service provider applications. Luis?
Thank you, Alan. Like we said before, for wireless service providers, we have seen folks using our RF signal generators to mimic what you would see in your typical Wi-Fi or Bluetooth frequencies for your devices, in regards to making sure that their transceivers are putting out signals within their bandwidth and they're not impeding on others. Also not spoken about today, but in other aspects, we do have spectrum analysis equipment, so that way you can see that your frequency that you're outputting is within its proper band as well. And so that is where we can support WSP endeavors.
Yeah, and we work with some very sophisticated companies here in the US with regards to WISP antennas, net point, great when it comes to quality and performance with antennas. So they use uh, from a wide range of frequency with our signal generators. They're able to test the performance of their antennas point to point. So with regards to RF, we not just specific to the signal generators, we have antennas, we have um, RF power meters, VNAs, phase noise test systems. So again, reach out to us. And if we don't necessarily have some of these amplifiers that you're looking for, Edgar, our engineers here, could recommend something for you that should meet your requirements. Okay. Any other questions that we see there?
Do we answer the internal amplifier question yet?
No.
So some of our units have HP option that allows them to have the higher um, output power setting, but that's dependent a lot on the unit itself. I, I don't know if that's a physical amplifier. I would have to check, but it only goes up a few more power. But it's if you need to push it up to like 26-ish dBm around there. Once again, depending on the model.
That's a good question. And I got a message direct if we are going to go higher channels, higher density. Um, it's not on our website, but we will be coming out with a high density RF signal generator. So this is kind of breaking news to the people here, but we will be coming out with a uh, an instrument that will provide more than 4 8 channels. How high are we going to go, Edgar? Do we know yet with the initial launch with regards to the channels in that high density version?
I think that's still being kind of settled on because there's a lot of factors you have to take into account: form factor, all that, how many channels you're fitting into a singular chassis.
But it is going to be more than 10. And again,
I
like
believe,
Edgar
yeah,
said, we are going to be, it's going to be dependent on the customer, but it's going to be a new high density option that, depending on applications, quantum, and other other customers, that will be launched in the upcoming months. So check out. Feel free to check that out as soon as it's available. Anything else? Any other questions for the engineers? Anything else? Luis, anything else before we sign off?
I think we covered everything down to the basic level, which is good. Generally, when there's not too many questions, it's because everyone understood everything. So we're glad. We hope to help. Again, please don't be shy. If there's something on your mind, please let us know. But otherwise, I think we covered everything on our end. Edgar, please chip in.
Yeah, all
yeah.
good.
I think that was everything. Yeah, if you guys have questions when this is over, just feel free to shoot them over to us. Give us a call, even.
Yeah. So, again, thank you so much for attending. We'll send a link to you if you missed a part of it, or if there's information that you need uh, to maybe send off to your colleagues. We'll be sending you that shortly. But yeah, feel free to check out our website. It's a great resource for videos, spec sheets. We have case studies where we have other customers that have already used this equipment. That might provide you with either more guidance or allow you to determine where to go. But definitely go to our website, www.berkeleynucleonics.com. You'll find our information there. But again, on behalf of myself, the engineering team, everyone here at Berkeley Nucleonics, thank you for attending. And as always, if there's anything we could do for you, by all means, let us know.